Today we want to talk about a new research paper titled, Arc-Discharge Synthesis of Chitosan-Mediated Copper Nanoparticles for Heterogeneous Catalysis in 4-Nitrophenol Degradation. In this research, copper nanoparticles were produced by the electric arc discharge method without the use of a reducing agent and only by the electric discharge method. This research published in Particle and Particle Systems Characterization Journal in Wiley Publisher. The authors include Noor Azfarina Ahmad, Mohammad Taghi Hajibeji, Mohsen Nabi-Pour, Aris Kartuzian, Hassan Moaini, and Kamir Shamilai. From Malaysia-Japan International Institute of Technology, University Technology Malaysia, Taylor's University, Nanosonics Limited Company from Australia, Catalysis Research Center and Chemistry Department and School of Medicine Technical University of Munich, Germany. The general schematic of the preparation of copper nanoparticles showed that the plasma nanocolloid maker by PNF utilizes high-purity copper wires as electrodes for arc discharge experiments in distilled water, controlled by constant currents and electrode spacing. Arc discharge vaporizes copper electrodes, leading to nucleation and formation of copper nanoparticles dispersed in chitosan dissolved in water, facilitated by gas bubbles. Physiochemical analyses reveal chitosan's dual role as a size controller and stabilizer, confirming the efficacy of arc discharge for copper nanoparticle synthesis. UV-vis spectroscopy analysis reveals chitosan stabilizes and caps copper nanoparticles, aiding in pure copper nanoparticles formation. Colloidal copper nanoparticles are confirmed, showing surface plasmon resonance absorption peaks at 572 to 585 nanometers. Higher chitosan concentrations lead to sharper peaks and blue shifting, indicating smaller copper nanoparticles and enhanced dispersion. X-ray diffraction analysis showed that confirmed synthesis of pure and crystalline colloidal copper nanoparticles. Peaks correspond to face-centered cubic (FCC) copper nanoparticles crystals in distilled water and 0.10% chitosan solution. Lower intensity of XRD peaks in chitosan solution indicates smaller nanoparticle sizes due to interactions with the stabilizing medium, contrasting with distilled water synthesis. Fourier transform infrared spectroscopy analysis showed that reveals distinct molecular interactions in chitosan-mediated copper nanoparticles and those synthesized in distilled water. Shifts and appearance of new peaks in chitosan-mediated spectra confirm NH groups from chitosan capping copper nanoparticle surfaces, with additional peaks indicating copper nanoparticles presence. Peaks in distilled water synthesized spectra suggest interactions between water molecules and copper nanoparticles. Transmission electron microscopy analysis showed that size reduction of copper nanoparticles with more chitosan, confirming its role as a stabilizer. Nanocopper in water have larger size ranges than chitosan-mediated ones, showing more uniformity with chitosan. Chitosan effectively controls copper nanoparticle size, supporting its use as a stabilizer in nanoparticle synthesis. Heterogeneous catalysis of copper nanoparticles in 4-nitrophenol degradation showed that copper nanoparticles catalyze the reduction of 4-nitrophenol to less toxic 4-aminophenol, as indicated by color fading and UV-visible peak shifts. Synthesized in distilled water, copper nanoparticles exhibit faster reduction rates than in 0.10% chitosan solution, completing the process in 32 minutes and 72 minutes, respectively. Reduction process efficiency depends on factors like nanoparticle size, 4-nitrophenol diffusion rate onto copper nanoparticle surfaces, and electron transfer rates, influencing reaction kinetics. Finally, the conclusion section was shown. Nanocopper synthesized via arc discharge with chitosan as a stabilizer exhibit monodispersed colloidal properties, with size controlled by chitosan concentration. TEM analysis shows nanocopper sizes ranging from 14.62 to 43.06 nanometers, correlating with different chitosan concentrations, while XRD patterns confirm pure nanocopper formation. Catalytic reduction experiments reveal that chitosan's inflexibility around nanocopper hinders surface area, slowing 4-nitrophenol to 4-aminophenol conversion compared to nanocopper in double distilled water. Despite larger sizes,
Nano copper in double distilled water show faster reduction rates, completing in 32 minutes, while those with 0.10 Wt% chitosan take 72 minutes. These findings highlight the importance of stabilizer choice in nanoparticle synthesis and its impact on catalytic performance and kinetics.